Page 4, here we go. What is a periodic trend? A repeating pattern. That's what periodicity means. Periodic means that it repeats, and we definitely repeat. 1 valence electron, 2 valence electrons, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Define electronegativity. An atom's pull to gain an electron. Which element is most electronegative? Well, if you know the trend goes up and to the right towards fluorine. So that is fluorine. As you go across the period left to right, electronegativity increases. Because remember, the arrow points up and to the right. So that means it's increasing up and it's increasing to the right. And as you go down a family from top to the bottom, electronegativity decreases. Electronegativity values of the noble gases are 0. Why? They have 8 valence electrons. What does atomic radius measure? Size of an atom. That's all you're doing. You're just measuring the size of atoms, right? Okay, size of an atom. As you move across a period left to right, atomic radius values decrease. Because remember, now we're talking about the opposite. We're talking about the trend down and to the left. So everything to the left is bigger. Sorry, down and to the left. So everything to the left is bigger and everything down is bigger. On the bottom is bigger. Okay, so let's see. And as you go down a family, atomic radius increases. All right, what has the highest first ionization energy? Well, again, ionization energy, the trend points up and to the right. So I have oxygen, sulfur, and tellurium. Oxygen, sulfur, and tellurium. So as it's up and to the right, whatever's on top is going to have the highest. So oxygen, the largest radius. Oxygen, sulfur, and tellurium. So whatever, that trend is down and to the left. So whatever's on bottom is going to have the largest radius. Tellurium, lowest electronegativity. Well, electronegativity is up and to the right. So if I want the lowest between oxygen, sulfur, and tellurium, it's tellurium. Okay, and then highest electronegativity, and they've got sodium, rubidium, copper, nitrogen, fluorine, hydrogen, or helium. So fluorine is going to have the highest. It has the highest on the table. Highest first ionization energy, that is helium. Because remember, electronegativity includes everything but noble gases. Ionization energy includes noble gases. So the highest electronegativity is fluorine, and the highest ionization energy is helium. So first ionization energy, helium. Yep. Largest atomic radius. So what's farthest left and at the bottom? So let's see, we got rubidium. I don't think anything's left or further. Copper. We have sodium. Nope, that's farthest left and farthest bottom. So that is my largest atomic radius. If you don't know why, you're going to need some help on trends. I mean, I'm just, let's see, let's draw some little mini periodic tables here. We're going to do ionization energy. And we're going to do electronegativity. And then we'll do atomic radius. All right. So ionization energy is up and to the right and includes everything. Electronegativity is up and to the right and doesn't include noble gases. They don't have any pull for electrons because they have 8. And atomic radius points down and to the left. Those are the 3 trends I really need you to know. See my little atomic radius down and to the left, everything else up and to the right. Okay. Let's see, based on the picture, which set of numbers would make the most sense for the atomic radii in the missing box? Well, in the missing box, I'm going from right to left, left to right, from larger to smaller. So, and as magnesium was 160, it'll have to be smaller than 160, but only just. And then it'll have to go down to something bigger than 70. So 98, nope, that's too big a drop off. And it goes up. 143, 118, 110, 103, 99, 98. That's a possibility. I like that one. 72, no, that's too big a drop off. 44, yeah, so B is my answer. So I can write them in and they make sense. 143, 118, 110, 103, 99, 98. That makes sense. 31, 70, 98, like a jump. Perfect. Which subatomic particle identifies the atom? The proton. It's the one thing you can't change. Unless you have an atom smasher, you don't get to change the number of protons, whereas electrons are changing all the time, and neutrons only identify a isotope of that element. Okay, you're going to love this. All right, atomic mass of calcium. Well, there's only one place to get the atomic mass, and atomic mass for calcium is right here. 40.1. I think they're looking for mass number, but they put atomic mass on their review, so let's just run with it. Atomic mass of aluminum is 27.0. Remember, atomic masses are the weighted average of all the isotopes. That's why you get these not whole numbers. Iodine is 126.9. Okay, now I got to identify a couple of atoms. The atomic number 17, that makes it chlorine. And number of protons 29, that means it is copper. Okay, 17, 29. Remember, A equals P equals E. So atomic number equals protons equals electrons. 17, 17, 17, 29, 29, 29. Iodine. Iodine has 53, 53, 53. Aluminum's atomic number is 13, so it has 13 protons. Okay, now let's talk about this ludicrous number here. 24 electrons. Aluminum has 3 valence electrons. So it is going to tend to lose 3 electrons and be charged plus 3. So the number of electrons aluminum can have is either 13, like in its normal state, or subtract 3 electrons from that, 10. So aluminum can have 13 or 10, but what aluminum can never, ever, 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 ever have is 24, like this review says. Okay. Atomic mass for chlorine is 35.5. Atomic mass for copper is 63.5. Atomic number for calcium is 20, so it has 20 protons and 20 electrons. Okay, now to get the number of neutrons, we'd have to have one specific isotope. Well, here they gave us one specific isotope. They gave us calcium 42. So all I do is subtract the number of protons from the mass number. Remember, mass number is protons plus neutrons. 42 minus 20 gives me the number of neutrons. But here we don't have a mass number. Now, I can assume that it is the most common isotope or whatever this rounds up to, but that's a bad assumption. So I really don't want you doing that. But today we're going to have to, right? So we're going to say that the atomic mass of this particular isotope of aluminum is 20, or the mass number is 27. 27 minus 13 is 14 neutrons. Iodine, closest thing is 127. 127 minus 53 is 74 neutrons. Chlorine, it's closest to 36. 36 minus 17 is 19 neutrons. Okay, ion. Well, this has the same number of protons and electrons, so it is not an ion. This could be either way. If it's that one, it is an ion. If it's that one, it isn't an ion. So I guess you're going to have to make a command decision. And none of the rest of these are ions because they have the same number of protons and electrons. There's no charge there, therefore it is not an ion. This is the only question mark, and it just depends on how the person who wrote the review wants it answered. So, okay, so that is 4 pages in the books. All right, let's go ahead and do page 5 since we're here. We're gonna do page 5 since we're here, and okay, and try and squeeze this one in the video too. An element that cannot conduct electricity is dull and is found on the right side of the periodic table would be classified as a non-metal. A non-metal, right? It's to the right of the staircase. It's dull, whereas metals are shiny, and it doesn't conduct electricity, so it is non-metal. List the properties below. Metals are shiny and usually silver, usually, not always. State of matter. Metals are all solids. Conductive, yes, they conduct electricity. React with acid, yes, you've done that. You've put magnesium ribbon into a test tube full of hydrochloric acid. It produced hydrogen gas, and then you lit that hydrogen gas on fire, and a little test tube went boop. Location in relation to the staircase, metals are to the left. Everything to the left of the staircase is a metal, right? So left of stair step. What type of ions do they form? Cations, of course. Metals all positives, and these are positive, and those are positive. Okay, nonmetals. They are dull, usually. They can be solid, liquid, or gas. They do not conduct electricity. They do not react with acid. They are right of the staircase. And they normally form anions, right? Minus, minus, minus. Okay. Metalloids. Appearance. Well, I'm going to use silicone as my metalloid of choice here. And silicone is shiny. And state of matter, it is solid. But I'm going to specify that I've picked a metalloid. I've picked one metalloid, just in case you pick a different metalloid. Is it conductive? No, it's not conductive. Does it react with acid? No, it doesn't react with acid. Location. Metalloids are on the stair. And what type of ions? They can make cations or anions. Right? Because here I have silicon. It can make plus or minus 4. Boron, which is a metalloid, and it's a plus. Tellurium is a minus, right? Okay. Which of the following contains a metal, non-metal, and metalloid? All right, let's just go through the list. Aluminum, that's a metal. Carbon is a non-metal, and silicon is a metalloid. Oh, wow, I found it. That's convenient. Let's just make sure there aren't any other answers. Lithium and calcium are both metals. Copper and sodium are both metals. Argon and phosphorus are both non-metals. So, yeah, I found the only right answer. You're just looking for something left of the staircase, something on the staircase, and something right of the staircase. During the flame test, as the solution is heated, electrons move from the ground state. I'm going to draw a picture here too. So here is period 3 and period 2. So basically shells. That's the second shell and third shell. And here's my electron. And it moves up from the ground state, this is ground, to the excited state. And then it drops back down to the ground state. And when it does, it gives off light. So ground state to the excited state. And as the electrons fall back to ground state, they release energy in the form of light. That was old Niels Bohr. Niels taught us that, so we like Niels Bohr for that reason. All right, given the orbital diagrams below, circle and explain which one represents the most stable element. Okay. I think they mean least reactive. Most stable, again, when you get into college chemistry, the only time you talk about stability is when you talk about radioactive, and we're not talking about radioactive. So what they mean is least reactive element, and the least reactive stuff is noble gases, and they all end in P6. This is the P block. P1, P2, P3, P4, P5, P6. That's 2P6 is neon. Argon ends in 3p6, krypton ends in 4p6. So, given the orbital diagrams below, circle and explain which one represents the most stable element. So I'm looking for a full p orbital. Well, this p only has 3 electrons in it, so it is not full. This ends in an s orbital, so that is not it. This p orbital, oh my god, you can't even see what I'm looking at here. That's great, John. Great, great. You're great at this. This p orbital has 3 electrons in it, so it is not full. That is 2p3. That would be 2p1, 2, 3. That would be nitrogen, is what I'm looking at right there. Nitrogen. See here, I'm looking at ends in 3s2. That is 3. I'm going to go back and forth here. 3, S1, S2, so that's magnesium. This one here ends in 3p. 1, 2, 3, 4. So third layer, 1, 2, 3, 4. That is sulfur. And this one ends 2p6. So that is my noble gas. 2p6. That is neon. That is neon. So that's how I tell which elements I'm looking at. Identity of the element, that is nitrogen. Identity of B is neon. Identity of C is magnesium. We're going to just do this and this. Okay, there we go. Magnesium. D is sulfur. Family, nitrogen, noble gases. Magnesium is an alkali earth metal. And sulfur is part of the oxygen family. Valence electrons. Nitrogen has 5. Neon is a noble gas, it has 8. Magnesium, and it's an alkali earth metal, and it has 2. Oxygen has 6. Metal, non-metal. Nitrogen is non-metal. Neon is non-metal. Magnesium is metal. And sulfur is non-metal. Sulfur, yeah. 6, same. Okay. Identify the elements. 4p2. 4p1, p2. Germanium. That's how I do it. Germanium. There we go. Told you I was going to... Germanium. Yeah, I'm spelling things wrong. I know I am. Germanium. No, I seem to have gotten it right. All right. 2p4. 2, 1, 2, 3, 4. Oxygen. That's how I do it. But you do it the way you need to best. Like if you need to take helium's number of electrons 2, and then add everything that you see here. 2 plus 2 is 4, plus 4 is 8. 8. If I have 8 electrons, I am oxygen. So 2 and 10 is 12, plus 2 is 14, plus argon has 18. 14 plus 18 would be what? 14 plus 9 is 20. 14 plus 14 plus 18. I can't even do math anymore. That's 32, right? 32. Okay. Yeah, so it has 32 electrons, and I can look on here and go, 32 electrons is definitely germanium, and there we are. All right, starting a new video with page 6.